An engineer is a person that solves problems.
And a chemical engineer is somebody who knows enough mechanics to confuse a chemist, enough chemistry to confuse a mechanic, and enough math to confuse himself.
People come to us with ideas, innovations, new technology, and they want to scale it up. They want to take it from something that's a beaker size and make it bigger, and we do it in an economically viable way. We had a client come to us, and they wanted to attempt to make textiles out of stinging nettle, which is a weed. So we took the material that they sent us and we put it through our small-scale processing system, pulped it, and then we put it through an extruder to extrude it into a fiber. And that fiber can be woven into textiles.
The fibers that they're making with stinging nettle now are rayon-like fibers, which come from renewable feedstocks versus polyester, which are petroleum-based. So taking a renewable feedstock and offsetting a petroleum-based feedstock is better for the environment.
So waste can actually be valuable instead of being detrimental to the environment.
There is no such thing as waste. Whenever you're taking something and you're making something else, you're going to be doing an impact to the environment. You just want to make sure you minimize that wherever possible. And it's the responsibility really of chemical engineers to make sure that that impact is minimized. I think at one point engineering actually used to be something that you became. Right now I think engineering is a lot more evolved into a skill set or a way of thinking that allows who you are to actually benefit the world by solving problems, by doing interesting things.
Hi, I'm Laura.
And I'm Wade.
And we're chemical engineers. My favorite thing about chemical engineering is talking to clients and solving problems.
Well, I have a passion for processes. I don't know what it is. I can walk into any industrial process and I'm like a kid in a candy store. Ooh, there's shiny equipment over there. Ooh, I wonder what that's doing over there. Oh, look at that sample running over there. So I get really excited about it, and people can sometimes pick up on that enthusiasm and they can really work with me, or they'll want to engage me and they'll want to start trying different things and seeing what is possible, which is kind of nice.
And I'd say I have a passion for people. And so I love talking with people. I love sitting down with them and figuring out, listening to them and really helping them pull out what it is that they want from us and what it is that their problem is.
There are only two types of engineers, those that are chemical and those that wish they were chemical. It is the best job, it is the best discipline within engineering, and I love it.
As a chemical engineer, you have to realize that you solve problems as a team. It's one of the things I love most about chemical engineering is that I get to work with lots of different people all day long.
The skill set it takes to go from concept all the way to finished product includes scientists, engineers, technologists, and operators. And we as chemical engineers really take that middle part between the scientists and the technologists in order to design the middle piece and get it to go.
I love dividing the teamwork up and then coming back together and really sussing out that problem.
It's all about resolution of conflict. When you actually have an interesting problem and an interesting challenge and you can haul out a bunch of different resources, apply those resources and come up with a resolution to a problem, there's no greater feeling in the world. You have to love to solve problems and you have to be able to work with other people, simply put.
Who's the better chemical engineer?
She is. In the province of Alberta, our industry uses wood to manufacture pulp for paper. Wood, in particular hardwood, is very similar to cereal straw, yet there's an awful lot of cereal straw in the province that goes unused. And the opportunity to use that as a feedstock to make paper that will also benefit farmers by allowing them to sell some of their residuals is definitely an economic benefit to both industries.
A portion of our projects actually go into building a factory or into mass production, but a large portion of our projects don't end up going anywhere at all. The process of research and development will sometimes find that nothing comes of it because it's not economically viable or it's just not even possible to do it. One of our co-workers met with a local skateboard manufacturer, and in talking to them, they discovered that we use industrial hemp. And so we wanted to do a project with them and make skateboards out of industrial hemp. And so we were able to take the hemp from the farmer's field and we put it through our decortication pilot plant in Vegreville. So that plant takes big round bales of straw, chops them up, separates out the fiber portion, and that fiber portion is what can actually be woven into a mat. That mat then is taken and laid up and blended with the resin, and then it's formed into this skateboard shape, and you put wheels on it, and then we did races down the hallway. After it was done, we just had a whole bunch of people say to us, "I'd really love to have a hemp skateboard." The idea of it was just really cool. So now we're working with the client to actually scale up the process so that they can produce a lot more of these skateboards.